Let's talk about the focal length. So focal length for a convex or a concave lens is the distance between optical center and principal focus on the principal axis. So if I have a convex lens, I have got point f1 and point f2. So this is the optical center, you can see O. So the distance between optical center and principal focus f1, the distance between optical center O and the principal focus f1 on the principal axis, this length or this distance is called as, come on tell me, first focal length, small f1. So for concave lens, it will also be a distance between the optical center O and the first principal focus, which is f1. So this is denoted by small f1. So focal length is the distance between optical center and principal focus on the principal axis. If it is distance between optical center O and principal focus f1, it will be first focal length, and if it is distance between optical center O and second principal focus f2, then it will be a second focal length called a small f2. Here it will be small f2. So we studied first focal length and we studied second focal length. So focal length for a lens, in short, it is the distance between the optical center O and the principal focus f, right? And this distance lies on the principal axis. If it is distance between point O and f1, then it will be first focal length, and if it is the distance between optical center O and principal focus f2, then it will be called as the second focal length. Now we will study the last term called as second focal plane. So I would say this is a plane, and I will draw a plane on the principal axis perpendicular to it and passing through principal focus f2. You can see the red line which I have drawn, this line is perpendicular to principal axis, okay, and this line is passing through f2. Remember, the plane perpendicular to principal axis and passing through second principal focus f2 is called as, come on tell me, second focal plane. It's called as second focal. So here it will be second focal plane. So the plane which is perpendicular to principal axis and passing through principal focus f2 is called as second focal plane. Now what is the significance of this focal plane, or you can say why do we study second focal plane? So I'll tell you the importance of f2 in both the case. So what is principal focus f2? I would say if the incident rays are traveling parallel to principal axis, see these are the incident rays, and these incident rays, we can say these are parallel to each other also. So I will call them a beam of ray, right? So here also I will have a beam of ray. You can see all these rays are parallel to each other, but this beam of ray is also parallel to, come on tell me, principal axis. Here also the beam of ray is parallel to principal axis. What I want to tell you is that if a beam of ray travels parallel to principal axis, if incident on convex lens, after refraction will meet at a point. After refraction will meet at a point, you can see. And here, if a beam of ray, if traveling parallel to principal axis, after refraction from concave lens, what you will see? That it appears to diverge from a point. This we studied in the previous definition, right? So a beam of ray traveling parallel to principal axis, after refraction meet at a point, or after refraction appears to diverge from a point, but remember that point lies on principal axis. That point lies on principal axis, and that point is called as second principal focus f2. But what if the beam of ray, you can say this is also a beam of ray, this is also a beam of ray, that means all the rays are parallel to each other, but what is the difference over here? That this beam of ray are not parallel to principal axis. So if a beam of ray, right, if a beam of ray passes through convex lens, then after refraction they also meet at a point. You can see they are meeting at a point. If a beam of ray passing through concave lens, then after refraction they are also appear to be diverging from a point, right? But when the beam of ray are parallel to principal axis, remember that point lies on the principal axis. But here when the beam of ray are inclined or are not parallel to principal axis, they will meet at a point which lies on a plane. That point lies on a plane which is perpendicular to principal axis and passing through principal focus F2. Here, when the parallel beam of ray gets refracted from concave lens, they appear to be diverging from a common point. But remember here, the common point lies on principal axis. Here, the common point lies on second focal plane. That means the common point lies on a plane which is perpendicular to principal axis passing through F2. So this is the significance of second focal plane. So if a ray, remember, traveling parallel to principal axis, after refraction will meet or appear to be diverging from a point on the principal axis. If a beam of ray after refraction through convex lens will meet at a point, and after refraction through concave lens will appear to diverge from a point, but remember that point will lie on a plane perpendicular to principal axis passing through second principal focus F2. This is the difference between the second focal plane and the second principal focus F2. So how to draw this ray? How to get this point? So remember this, I will name it as a first ray. What I have considered, a ray passing through optical center, then definitely it goes undeviated. A ray passing through optical center will go undeviated. Then I know the path of this ray, that after passing through it goes undeviated, then definitely it is intersecting at a point. So if you want to get a point where all this beam of ray converging, what you need to do, you just consider a point F2, draw a second focal plane. Okay, draw the ray which is first passing through O. So the point where this ray meet, other ray parallel to this ray will definitely meet at this point. This is very important. So you can name it 2, you can name it 3. Other ray parallel to the first ray will definitely pass through this point. And here also I will consider this as the first ray. So what I have done, I have drawn this ray passing through O will travel undeviated. Then definitely other ray which are parallel to the ray 1, which is 2 and 3, will appear to be diverging after refraction from this point.